speaker who is joining the event today is Mr. Son Baekbeng, PhD, is the Deputy Director of Mine Reclamation Corporation, or MIRECO, Korea. To everyone, which I cannot mention one by one, but it does not diminish my respect. Let's ask the thanks for the present God to Almighty for all His gifts, so that we can gather in the Zoom room in this in the International Insight PP Bandung Polytechnic Energy and Mining Bandung webinar Arsenic Contamination in Groundwater with Mr. Sumbek Beng. Thank you and best wishes to the Prophet Muhammad SAW. Allow me Alfatur Rizky from the Meteorological Technology Study Program as a presenter, as a host. I hope the event will run smoothly and smoothly until the end of the program. Amin amin ya rabbal alamin. Name of event is Webinar Insight 3.0, stand for Inspiring Your Perspective Psych by PP Bandung. This event is being held to educate audience about the topic arsenic contamination in groundwater. Meanwhile, today's schedule includes point one, a presentation of the material is going to be presented by Mr. Sembek Beng, PhD, which is going to be with the moderator, Ilham Nur Hakim. Point two, there is also a Kahoot games with every very interesting door prize for the 3 lucky people and 2 best question. The last one is join photo and closing. So stay tuned until the end of the event. And now we have Mr. Dr. Asep Rohman, STMT, Honorable Director of PP of Bandung, Bapak.
Maka Pak Asep, punten.
Terima kasih Mas Fatur, terima kasih Pak Teddy. Thank you Mr. Bang for sharing with us. Assalamualaikum warahmatullahi wabarakatuh. Mr. Bang, Yunsu, sorry if I misspelling your name. Thank you Mr. Bang for sharing your knowledge and experience, and this international webinar series is part of collaboration implementation between PEP Bandung and MIRECO, and hopefully there will be other debug and beneficial activities in the future for all of us. Debug, is it correct? Amazing in Korea, or in Korea language. And saya juga mengucapkan terima kasih kepada teman-teman PEP yang telah mempersiapkan ini semua. Pak Teddy, terima kasih, dan saya yakin ini akan menjadi sesuatu yang bermanfaat buat mahasiswa kita semua. Thank you, Mr. Bang, terima kasih. Sekali lagi, terima kasih. Hatur nuhun, Kang Debat. Kang Bang, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir, for the remarks that have been given. The next is prayer to the main event. Let's us pray according to our perspective belief. Praying begins.
Maybe I want to.
No, thank you. Yes. Okay, the next event is our core event, which will be hosted by my brother Ilham Nur Hakim from the Mining Technology Study Program. He is education, the public senior high school of the 6th of Bandung, period 2017 until 2020, and Polytechnic of Energy and Mining Bandung 2020 until present. And awards is one winners of National English Speech Contest Bandung, Dreaming at Institute Technology of Bandung, period March 2018. And experience is marketing and communication assistant in family business, period February 2016. To Ilham Hakim, time is yours.
Fatur, I'm sorry, can I speak a little bit?
Oh yes, yes sir.
Okay, Mr. Bang and Ms. Yonso, I would like to say an apology because actually I cannot join this meeting until the end of this meeting because I have to give some lecture to the mining company today related with the mine reclamation and mine closure. And my schedule is from 8 to until 12. So yeah, I'm really sorry I cannot join this webinar until the end of this webinar. So nice to meet you, Miss Yonso.
Yes, Miss, just call me Miss O.
Miss O, okay, Miss O. I'm waiting for your picture because we have to make a flyer for another webinar next Wednesday.
Okay, then I will send you by email my picture.
Okay. Thank you. Pak Sep, punten ya Pak Sep, saya mau ngajar bintek. Ini kebetulan sudah mau mulai.
Mangga Pak Tadi, silakan.
Oke, thank you. Oke, Mr. Bang, thank you.
Thank you, Pak. Okay, repeat again. To Ilham Nur Hakim, the time is yours.
Okay, thank you so much, Father, and good morning, everyone. Welcome to Webinar Insight 3.0. Thank you all for finding the time and visiting today's webinar. First, let me introduce myself. I'm Ilham Nur Hakim from Mining Technology Batch 2020, and I'll be responsible for hosting this webinar today as the moderator. I'm glad to welcome Mr. Sonbaek Mang, PhD, as Deputy Director of Mine Reclamation Corporation, Korea, who will present the topic today. Now I will ask you one question to check if you can see and hear us well. Do you hear me well? Okay, good, great. Our topic today is arsenic contamination in groundwater, and the speaker is Mr. Sonbaek Mang, PhD. Before we start, let me explain how you can talk to us during this webinar. If you are wondering and have any questions during the presentations, write them to chat in the Q&A session. The format is the name/origin of the institute/the question. The chosen questions will be answered by Mr. Sonbaek Mang. There will be special door prizes for the two best questions. And during this special webinar, we are going to use English for the next 2 hours. So just in case you have some questions, make sure they are in English. You are allowed to use Google Translator or any translator website to help translate the question as well. There have to be at least 2 questions each batch from batch 2019 and 2020. Now let me tell you a brief resume of Mr. Sonbaek Mang, PhD. Mr. Sonbaek has excellent experience in the mine reclamation field. He is now undertaking as Deputy Director of Mine Reclamation Corporation, Korea. The educational background of Mr. Sonbaek Mang is Doctor of Philosophy in Environmental Engineering in Stevens Institute of Technology, USA in May 2003, and then Master of Engineering in Environmental Engineering in Stevens Institute of Technology, USA as well, in May 1998, and then Bachelor of Science in Civil Engineering in Daejeon University in South Korea in February 1995. Mr. Sonbaek has tons of beyond words professional careers as well. Some of them are technical expert in the Committee of Grand Aid, Ministry of Foreign Affairs in Korea, starting from February 2020 until present, and then Deputy Director, Mine Reclamation Corporation in Korea, starting from January 2018 until present, and an expert advisor in Korea International Cooperation Agency, or KOICA, in Korea, July 2017 until July 2019. And so many other wondrous professional careers of Mr. Sonbaek that I can't mention one by one. So, ladies and gentlemen, without any further ado, let us welcome Mr. Sonbaek Mang, PhD. How are you, sir? Oh, I guess, Mr.
Thank you. Yeah,
Okay.
thank you very much for your introduction.
Yes, sir.
Yeah,
How are you?
So, yeah, I'm fine.
Okay, great.
So, can I share my presentation?
Yes, sir. The time is yours.
Okay. Yes. Can you hear? Okay. Yeah. So today I want to talk about the arsenic contamination in groundwater. Actually, I live in Bandung for 2.5 years. I was a citizen in Bandung, so it's my like a second hometown. Bandung is my second hometown. So I lived in Gegerkarong.
Gegerkarong.
With my family, yeah, with my family. So I'm very pleased to have a webinar with Pepe Bandung. So recently we had like a memorandum of cooperation between Pepe Bandung and Mireco. So we're gonna start up our relationship and cooperation. And I hope we can have with more like research work and then more like education work, like related to the other seminar or webinar, or so we're gonna have with more collaboration work. So I wanted to start my presentation. So the arsenic is not big issue in Indonesia, but this is a big issue in worldwide, especially the other country, especially in Bangladesh has a big problem. So most of their groundwater like contaminated by arsenic, and then Vietnam also. So I conduct several their project in Bangladesh and Vietnam and US, and then I want to share that kind of like experience and then my research work. And then also I did some work in with the DGMC, so 3 years ago. So I want to show the one example. That one is not related to the other arsenic contamination in groundwater, but this is arsenic contamination in soil, and then like this related to the other mining activity. So I'm gonna share that kind of information with you. So maybe you don't know what is arsenic. So I want to introduce what arsenic is. The elevated arsenic concentration is found in groundwater and surface water due to the anthrogenic activity and natural processes. There is a two-way. Arsenic can release from anthrogenic activity. One of the big anthrogenic activity is mining activity. In Korea, we have a lot of gold mine. So in Korea, so usually gold is associated with arsenic. So once we generate a lot of mine tailing, they're containing a lot of arsenic. That one leached out from the tailing and then is contaminated to the other soil and water in Korea. So this is a big issue in Korea. So we are trying to remediate the other soil in Korea. So mainly the Miracle doing that kind of work. So here is anthrogenic activity, including the mine, use of arsenic as a pesticide. But recently we are not using this is arsenic pesticide, but we used to use that one. And then herbicide, and then the crop is a desiccant. And then release of industrial effluent and the disposal of chemical waste. Another natural occurring arsenic is from the reduction of iron hydroxide and oxidation of arsenic sulfide to mineral. That is two processes, the main natural processes. So natural occurring arsenic is often found in groundwater in many countries in different parts of the world. The elevated arsenic concentration is found in Bangladesh and China, India, and Mexico, Vietnam, and United States, affecting over 100 million people worldwide. Arsenic can cause liver, lung, kidney, and bladder cancer, as well as skin cancer. So arsenic is very harmful because this is a carcinogen material. This one shows the symptom of arsenic poisoning. So this is the Bangladesh case. So they drank their arsenic contaminated groundwater for more than 10 years. And then they found that kind of symptom. And then so we check it, why it happened. And then we're trying to find the solution, what it is the cause. And then finally we found it, this is caused by the arsenic. contaminate groundwater. So later, usually the concentration of arsenic in Bangladesh is around 300 ppb, microgram per liter. So, but what WHO standard is 10 ppb. So is their concentration is very high. It's more than 30 times higher than the WHO standard. Here is a International Agency for Research on Cancer, IARC, mentioned that like arsenic is a carcinogen to human in 1980, and the World Health Organization (WHO) set the maximum amount of like arsenic as like a 10 ppb. And then European EU also set the standard for arsenic as 10 ppb in 1998. And then Vietnam they set the drinking water standard as 10 in 2002. United States follow change the standard from 50 ppb to 10 ppb in 2006. And then Korea is change the drinking water standard to 10 ppb in 2011. I don't know the Indonesia. I trying to find out trying to search for the drinking water standard for arsenic in Indonesia, but I couldn't find it. Maybe in Bahasa Indonesia. So maybe 50 or 10. Yeah. So this one is there are a lot of arsenic species. We just call the arsenic, but this arsenic can be separated by the inorganic arsenic and organic arsenic. And then organic arsenic can be divided by classified as like arsenite, arsenic 3, arsenate, arsenic 5, and then elemental arsenic, arsenic 0, and then arsine. Arsine is arsenic -3. There is a 4 species in as organic arsenic, but arsine is like a gas form, so it's very, very toxic. And then organic form, I'll explain the other. We call the MMA, monomethyllasonite, and then MMA, DMA, TMA, arsenobentane, arsenochlorine, and then arsenosugar. And then there are some species, 305 and 305. And then there are more arsenic species there. But the important thing is in naturally, most of form is arsenic. Inorganic arsenic form. So you don't worry about the organic arsenic form. But we can find the kind of organic arsenic form is maybe you can see the seaweed, dry seaweed. In Korean, like dry seaweed, a lot of organic arsenic in seaweed. But the toxicity is very low. So next slide, I will explain the toxicity. So this one is toxicity for arsenic speciation. So this is a lethal dose, LD50. Mean is if you dose this amount to mouse, so 50% of mouse is dead. So arsenic 3 is 14 milligram per kilogram. Arsenic 5 is 20 milligram per kilogram. MMA, DMA, arsenobentane. See, it's a big difference. So that's the reason if you consume the inorganic arsenic, is no problem. This is a pathway of biomethylation of arsenic. Usually arsenic 5 is reduced to arsenic 3. And then arsenic 3 reduced to become the MMA5. MMA5 become the MMA2, 3. And then they'll change it to DMA. And then DMA5 change it to DMA3, and then TMA5, and then TMA3. It's like adding isomethyl cations. So this is like a methylation system. So usually the other methylation, this one happen in like a sediment, anoxic condition. Oxic condition is not happen like this. So this one show the arsenic specialization in natural water. So arsenic, for example, arsenic 5, this is also common, but when arsenic 3 exists in natural at pH is less than 2, is arsenic H3ASO4 is a neutral species. But the pH increase to 4 example, they don't become the other minus, is an anion form. And then if we more than 7, so arsenic 5 change it to HASO4 2 minus. So more than 2.5, arsenic 3 exists as like an anion form. But the arsenic 3, before pH is 8.5, so arsenic 3 exists as a neutral form. So that's the reason it's very, very difficult to treat it. Very, very, very difficult to remove. So arsenide is very difficult to remove because of high mobility, because of no anion or cation form, neutral. But arsenate as a most of form is like anion, so very easy to remove. And then this is predominant in surface water. So you remember that. So this one is important of speciation. So this is arsenic 3 and arsenic 5. And so we using the ferric chloride to treat arsenic. So when you treat arsenic 5, when pH is increased, the efficiency, removal percent is decreased. So that's the important things. When we remove arsenic 5, and then we should keep the pH is less than 7.5. But in contrast, arsenic 3 is a low pH. pH is arsenic 3 removal is low, but pH increased to around 8.5 or 9. And then we can remove around 70% of arsenic. So this is very important for the other arsenic. Speciation is the most important part for the other understanding of arsenic treatment. For example, here you can compare here is a 8.5 arsenic 9 here and here. See 8.5 around 9. After 9 is changed to anion form. So that's the reason the removal percent is very high in here. So this one is a PE-pH diagram. So you can measure the pH with a pH meter, and then PE is you can measure with the redox potential electrode. Like we can call the millivolt. The unit is millivolt. So from that is if we understand the two, we can guess what kind of a species is predominant in surface water or like on the groundwater. Usually the arsenic 5 is predominant in surface water, but the arsenic 3 is predominant in groundwater because low around the 0 mean is like anoxic condition. This is oxic condition. And then also iron also has different form. So for example, iron 3, the ferrous plus iron 3 plus is when pH is less than 2, but pH increase is changed to around 3, iron changed to iron OH 2 plus. But after 3, pH is 3, ferric is like changed to ferric hydroxide. So usually the ferric hydroxide has the ability to absorb the other arsenic. So this is later I will explain that one more. So important thing is like analytical method of arsenic. So what kind of method is we can like equipment to analyze arsenic. The first one is a hydride generation atomic absorption spectrometry. And then second one is a graphite furnace atomic absorption spectrometry. We call the GFAAS. And then also we can using the inductive coupled plasma atomic emission spectrometry, Icp-Ms. And then also we can use Icp-Ms, coupled with the plasma mass spectrometry. So usually the Icp-Ms, it can measure the very low concentration. It's like theologically, we can measure the PPT level, but the real system, but we can analyze the PPB, is no problem. But ICP is theologically, we can measure PPB level, but it's very difficult to measure PPB, but it's we can measure ppm level will be okay with the ICP-OES. Then this is the GAAS and then GFAAS, we can measure the very low concentration, PPB level. So this is, I mentioned that the previous like a method, they can measure only total arsenic. And then I mentioned that we want to know the speciation, arsenic 3 or arsenic 5. That's very important. So there is a method, two kind of method. One is arsenic speciation column. So there, another one is arsenic exchange resin. See here, this is a commercial. This is I think we developed that one is when I studied in US. My advisor developed this arsenic speciation column. And then this is an anion exchange resin. This is a commercial one. So once we collect the other water, groundwater here, and then we filter, and the ore is like minus. Anion is trapped in the anion exchange resin. And then neutral species come out. I mentioned that when pH is 7, arsenic 3 is a neutral species. So that's the reason all arsenic 3 reached out, and then all is arsenic 5 is trapped in the iron exchange resin. So we can separate. The same, I mean, the way we apply that one. Arsenic 3 remain, arsenic 5 is remain in the arsenic speciation column, and then arsenic 3 is a come out. See, so is when we operate when we using the arsenic speciation method, we have to using pH is less than pH is 8. See. If pH is 8, is arsenic 3 is a neutral species. So all arsenic 3 is come out. So we can using that way to separate. Another method is we can using Hplc Icp-Ms. I already mentioned the Icp-Ms can detect the total arsenic, but the Icp-Ms can measure, can separate the arsenic 3 or arsenic 5. So we utilize the Hplc. So Hplc can separate arsenic 3 and 5. And then Icp-Ms can detect the total arsenic. This one is like we using this kind of e-route, and then we separate the arsenic 3 and arsenic 5 using the Hplc. This one is a sensitivity, is we separating. So for example, this is a intensity time. We put the 0.5, our peak is very small. So, and then is if integration time is 2 seconds, pH is peak is very high. So this one is a peak of arsenic 3 and arsenic 5 and the MMA and DMA. So we separate. So this is like a testing, how much a second we should apply. So we're gonna make the best optimum condition. This one is like a different injection volume. So we inject 50 milliliter and then 20 milliliter, 50 milliliter, 100 milliliter. Definitely we inject more samples our peak is sensitivity is high. So from that is we found is a best optimum condition. So we inject volume is 50 milliliter, and then we using this mobile phase is a route, and then this is the optimum condition. And here, and then is we make this one show the chromatogram of Hplc. So we inject 50 ppb of arsenic, and then this is a peak is arsenic 3, and then B peak is a DMA 5, and then C is a MMA 5, the D is arsenic 5. So from that is we can separate. And from that is we can make a calibration for each arsenic species. So arsenic 3, arsenic 5, MMA, and DMA. This is both of them is 5, MMA 5 and DMA 5. And then we can make a very nice calibration curve. And then the important thing is like a recovery check for arsenic species. So we made a solution, for example, arsenic 50 ppb. We made 50 ppb. So arsenic 3, 10, arsenic 5, 30, MMA 5, DMA 5. And then this is spike. Spike means we make this solution. And then we measured with the Hplc Icp-Ms. And then most of them is we get the number. That is a recovery percentage. And then this is a different kind of, total is 50, but arsenic 5 is 5, arsenic 3 is 5 ppb, arsenic 5 is 25, MMA, DMA is 10 ppb. And then we get the very similar recovery. And then also we had a different, like a 3, very low concentration of arsenic 3, MMA, DMA is 2 and 3 ppb, arsenic 5 is 42 ppb. But we get the measured. So from that is we can, using the Hplc Icp-Ms, so we can separate organic and inorganic, and then we can measure the arsenic concentration. So this is important because arsenic is what kind of, most important thing is like analysis, because we have to know what kind of form of arsenic, and then we can do the more research work. And then this is arsenic contamination in world. So in the world, so here is China, and then US, and then Brazil. And there is some big problem in Bangladesh here. This one, this is information of US. So lead mean is arsenic concentration is more than 50 ppb. Orange one is more than 10 ppb. So see, you can see a lot of area is contaminated by arsenic. So US is a big issue because especially the California area, they have no water, this desert area. So there's a lot of water utility developed the groundwater. But there are a lot of arsenic there. So there was a big issue. It was a very big issue in California. So their original arsenic quality is around 20 or 30 ppb, sometimes 50 ppb, but it's much higher than the US EPA standard 10 ppb. So they can, if they treat the arsenic, the cost is very high. So they just using their clean water, and then they mix, and then reduce the concentration, and then they release to the public. That is, they are using that method. Another one is I want to tell you about the Bangladesh project. So before that, I want to show the background of Bangladesh. Population is 120 million. As a GDP per capita is around $2,000. So around 50 to 60 million people is at risk for arsenic. The first official document of arsenic poisoning is 1992. potentially exposed population is 24 million, and patients suffering from arsenicosis is around 7,000. There are around is 5 million is a tube well in Bangladesh, but the other around 3 million of tube well is affected by arsenic. So this is an affected area. This is to show the map, arsenic affected area. For example, is green mean is more than 20 ppb. So you see, so most of the country is contaminated by arsenic. So this is very, very serious problem in Bangladesh. So when I studied in US, so we developed the sand filtration system for arsenic removal, because they have very poor. They are very poor. So we developed a very simple sand filtration. So see, only sand here, and then they just collect the water, and then we developed the tablet containing a lot of iron hydroxide, and then is a hypochlorite that is oxidize the oxidizer. We add that one, and then we add the 2 tablet into here, and then we mix it and then pour in our system, and then is arsenic is removed. So this one is a before and after. Well water is like before treatment. The filtered water mean is treated water after filtration. So it was 158 and the 11.3 like that. And then Bangladeshi standard is 50 ppb that time. So we reduced all the arsenic is below their standard. This is another research for related to the arsenic. BGW mean is a Bangladeshi well water, groundwater, and then NH mean is New Hampshire well water, groundwater. New Hampshire is one of the states in United States. The SB is a simulated Bangladesh water. So we collect, this is a characteristic of each groundwater. Arsenic is around 300 to 600 in Bangladesh water. Then New Hampshire is 70. And then simulated water is we made around 300. And then is we make this Bangladesh simulated water, and then we test it. So here, this is a Bangladesh water. Blue, it's a black circle dot. This is the Bangladesh water. We increase the other iron dosage, and then we can remove all the arsenic. For example, here is naturally arsenic. I will explain the natural iron and arsenic ratio. Mean is in Bangladesh there are arsenic in groundwater. At the same time, also there are iron there. So with naturally arsenic can remove all arsenic. But if you add arsenic, iron into here, we can completely remove arsenic. So this is a New Hampshire water. This is a cross one. This is a cross. And then even though we add a very small amount of iron arsenic ratio, we can remove all the arsenic. So we wonder why Bangladesh water is very difficult, but why New Hampshire, US water is very easy to remove. And then from that is we find out that is like we add New Hampshire water and then plus silica and phosphate. We add it. And then it was here, then that one change it to here, like a Bangladesh water. So the main difference between Bangladesh water and New Hampshire water, main difference is presence of silica and phosphate. So silica and phosphate, an ion can affect the arsenic removal. One of the reason is iron hydroxide, usually ozone, and then coprecipitate the arsenic ozone. But silica and phosphate also same time is ozone together. So they compete together. So that's the reason arsenic removal is a decrease. This one is show that this is Bangladesh groundwater. This is a Vietnamese groundwater. You can see big difference is that phosphate is 2.7, Vietnam is 6.4, much higher. So that means it's more difficult to treat it. Silica concentration also higher than the other Bangladesh. But the good thing is that iron concentration is very high in Vietnam, in naturally. So for them is that they don't need add any iron into their groundwater to treat it, because the iron is enough to treat arsenic. But the Bangladesh iron concentration is not so high. So that's the reason is that this iron can remove this arsenic completely. This is different. See, back to the other effect of anion on arsenic removal. If it's no anion, arsenic we can remove, even though arsenic 5 and arsenic 3, we can remove around 100%. But yeah, if you add bicarbonate, and the arsenate is okay, but arsenic 3 dramatically decreased. Night removal is dramatically decreased. So see, for the arsenic 3, I'll explain the arsenate first, arsenic 5. Arsenic 5, silicate and phosphate, and then bicarbonate, not much effect too individually. But if you combine with the phosphate with the carbonate, arsenic removal is decreased, arsenic 5. And then phosphate and silica decreased. Phosphate, silica, bicarbonate is decreased. So we found that one, this kind of anion effect. Then arsenic 3 has same thing. If with the presence of silica and phosphate, arsenic removal is dramatically decreased. This is also small, another same experiment, similar one. This is arsenic 5 removal. If we increase the bicarbonate, arsenic removal is the same. We can remove also of them. But if we add silica in here, you increase the silica concentration. So around 0.6 millimole, silica is no effect, but 0.7 after that is increase their effect for the arsenic removal. So this one is a phosphate effect. If you add phosphate here, itself is not much effect, but is combined with the bicarbonate or silica, arsenic removal is dramatically decreased. For arsenic 3, if you add the bicarbonate, arsenic removal was decreased to 100 to around 70% decrease. But if you add silica, further removal percent decreased to 50. But if you add phosphate, even though a small amount, arsenic removal decreased from 100 to 20%. So from that we found silica and phosphate, and then bicarbonate is the effect on the arsenic removal using iron. We found that one is from Bangladesh project. This is another project in Vietnam. Vietnam population is around 98 million, and then average they using around 30% using their groundwater in whole country, but 70% using the other groundwater in suburban area. So officially, first official documentation of arsenic contamination is 1999. So we conduct the several projects in here. This Hanoi is a capital city, and this Hanam province. Another project we had here, Mekong Delta area. This is a Hanam province here. This is show the sampling site. I collect the groundwater, like electric pump, and then there's a hand pump. And then we collect the other information, the well depths and the installation depths. Installation year. And then we measure the pH and the redox potential and then GPS point. So I mentioned that redox potential is very important to understand. And then Icp-Ms, we measure the like this kind of element using Icp-Ms and Icp-OES, and then AAES, and then TOC analyzer. So from that, we collect the sample in dry season and rainy season. And then we found it not much different. Redox potential is very low. That means it's like an anion, anaerobic condition in here. So they don't not affect rain, even though rainy season, the redox potential is not changed much. See, it's a dry season, arsenic concentration is around mean concentration 363, but most of the form is arsenic 3 form. And rainy season, the arsenic 3 is decreased a little bit. One of the reason is my assumption is that like rainwater get into the groundwater. That one containing some oxygen. That one effect to the oxidation of arsenic 3. See, so I compare the other seasonal variation of arsenic concentration in BT village, and then there is not much different. Not much different here total, but arsenic 3 is not much different. In treated, this is treated water. I did the speciation. And then this is to show the other characteristic of groundwater. And then we found the other barium and the iron and manganese has exceeded the other WHO standard. And then also Vietnamese standard. But other one is everything okay. So this one is show the oxidation of iron, ferric to ferrous, ferrous to ferric. Iron 2, when we collect the groundwater in Vietnam, very, very clear. And then if you put like that, and then after 5 minutes or 10 minutes, that one become yellow. That one is show the oxidation of ferrous to ferric. So that means is most of iron form in groundwater is a ferrous form, iron 2. Iron 2 is a soluble form. But once exposed to air, is oxidized and then become the ferric hydroxide. So that ferric hydroxide form can absorb the arsenic. So in Vietnam, they are very smart, and then they just they built a lot of sand filter, and then they treat the arsenic because they have enough iron in their groundwater. This is like their sand filtration system. So once they collect the water, put it here, this sand filtration, and then their iron is enough. So the iron can absorb arsenic. So it's clean water come out. So this is a sand filter, and then they put the groundwater here, and then they collect water, and then they using for their cooking or their washing. This is their sand filtration. So that's the reason, in Vietnam has not many patients because they always treat the arsenic because of their high elevated iron concentration in their groundwater. So they have to remove iron, but at the same time they can remove arsenic. But in Bangladesh case, iron concentration is not so high, so they can drinkable for their groundwater, but they are containing arsenic, so they don't affect to them directly. So in Vietnam, there's not many, patient, no patient. I couldn't find it. So also they are very smart. They make that one. See, there is a pipe. They put the some, the hole, and then that one is going to the here. So that one is a kind of aeration. They like exposed to air, to groundwater, and then that one oxidize it, and then clean water come out here, and then they collect. This is a reservoir, storage tank. So okay. So I found it approximately 90% of family has a central filtration system, and then that they to treat the other like arsenic and iron, and then 4 family are using groundwater without any treatment. Okay, 4 family is that they're not using filtration. So this is a percent sample having arsenic concentration higher than Vietnamese standard. So there's a Binh Thru village is 70%, or Ho Hao village is 50%. So Bode village has 50% is exceeded, but the they usually treat it. Most of people they treat the other like their groundwater, so that they have no problem. We also collect the other human hair samples. We collect their human hair, and then we analyze the other arsenic in their hair. So hair is one of a good indicator. So we can know when for example, like once you exposed to heavy metals, arsenic or cadmium or lead, whatever, once we collect the other hair sample, that one is accumulated. Like all heavy metals is not leached out and then stay in our body. So that's reason in hair sample is accumulated. So if you, for example, the man they cut their hair very short, so we can see the history, but woman has very long hair. So if you cut the woman hair, and if you cut, and then we can check. For example, if we here like a few years ago, 2 years ago or 3 years ago, like that. So we can guess when they expose their heavy metal. We can guess from their hair samples. So we collect the other hair samples. Then we get this kind of information. This is arsenic concentration in hair sample, the milligram per kilogram. This is arsenic concentration in treated groundwater because they drink treated water. See, we can see the correlationship. So they consume the more arsenic. There's more arsenic in their hair. So this is a real information. So maybe your case, I think in mining area, especially the not coal mine, the metal mine. Usually metal mine is usually contaminated by a lot of heavy metals. So especially arsenic and other things. So first we can collect the other soil sample, and at the same time, if we collect the other hair samples from them, we can know they expose their heavy metal or not. This is one of a good indicator. This is sampling site in Mekong Delta area. That time is I collect the other core soil samples. We make into the other 70 meter, and then we get this kind of core sample, and then we analyze the other arsenic and iron. Okay. And this is a concentration of arsenic and manganese and the iron. Average here is arsenic concentration around 100 in An Giang province. And manganese is 1,800, and then iron is 200. Iron is very high. See, this is the proportion of arsenic distribution. In An Giang province, is a groundwater less than 10 ppb is 59%. 59 samples are like less than 10 ppb, but 48% is more than 10 ppb. So we mainly focus on the other Anjang province. And that is manganese concentration, and this is iron concentration. So we found one thing here. Distance between tube well and Mekong River. If the groundwater, like a tube well, is located in like less than 2 kilometers between tube well and Mekong River, arsenic concentration is 99 samples are more than the 10 ppb, mean arsenic concentration 118. But more than 2 kilometers from Mekong River, arsenic concentration is 12, very low. We get the very similar information in Dong Ta province. Is from the 15 kilometers, arsenic concentration is 59, but more than 15 kilometers from the Mekong River, arsenic concentration is decreased. Another one is the depth of a well. Depth of a well is less than 60 meter, arsenic concentration is very high. So more than 60, arsenic concentration is 19. Dong Ta province is very similar. Less than 70 meters, arsenic concentration is high, but more than 70 meters, arsenic concentration is very low, 3. So that's the reason is we collect the other core sample. This is pH, okay. So this is a depth profile of soil-bound arsenic, manganese, and iron. So this is a core sample here. If we see the arsenic concentration is like fluctuated. This one, solid line. See, arsenic concentration is a drop here, and then increase here, and then decrease. And then iron concentration also here, same thing, is correlate with the arsenic concentration. And manganese is a different way. So from that, we can found that here, arsenic here, this zone, around 3 meter to around 75 meter, that sediment containing arsenic and iron. Like iron absorb the other arsenic, and then they become the sediment. They become the sediment. So that's the reason here a lot of arsenic is come out. So from that we can explain, around more than 80%, 80 or 60. If you make a very deep well, more than 100, there is no arsenic. So this is a concentration of arsenic and manganese and iron in groundwater in Anjang province. This redox potential and pH. One very unique things, like redox potential is high. Oxic condition, arsenic concentration is very low. But anoxic condition, arsenic is very high. So we found this one. And then see, most of arsenic 3 is like arsenic 3 form. See, you can see. Then we, using this data, we put this data into the PE-pH diagram. This is most of form is arsenic 3. See, here is arsenic is very low. Here, arsenic is very high. See, most of form is arsenic 3. And then arsenic iron form is a ferrous form. Ferrous can absorb arsenic. So that's the reason their arsenic and the iron concentration is very high. But here, arsenic is a arsenic 5 form. This is 5. And then iron is like a form is a iron hydroxide form. So iron hydroxide absorb the other arsenic 5. So they'll stay in the other underground. So that's the reason arsenic is not leached out. So when you measure the pH only, then we can guess from the Vietnamese case. This is arsenic is contaminated or not. We can guess, even though we are not analyzed the arsenic. So we found this kind of a conclusion in Vietnam. So maybe we're gonna share this one. Is the groundwater was severely contaminated by arsenic and manganese in Hanam and An Giang and Dong Ta province in Vietnam. No significant seasonal fluctuation of arsenic concentration and other parameters was observed between dry and rainy season. And approximately 70% of treated groundwater exceeded the Vietnamese standard arsenic. And the accumulate of arsenic in human hair has a relationship with arsenic level in groundwater. And then especially the arsenic concentration was found in shallow well along the Mekong River. So we can suggest don't make a shallow well, and then we should make a deep well. And then trying to not install any tube well in the nearby the Mekong River, trying to avoid the Mekong River, because this is like arsenic. There are big sediment there, and then there are arsenic. So we just guide them to how to avoid the arsenic in their groundwater. When pH groundwater is higher than 8, and TOC concentration is less than 1 ppb, and low arsenic concentration was observed. So this is another indicator that we can trying to avoid the arsenic contaminated groundwater. And okay, so arsenic concentration had a positive relationship with the iron concentration in core soil samples. And then most of arsenic groundwater exists in arsenic 3 species. It's a very toxic one. So we should oxidize it, and then we change it to arsenic 5, and then we have to treat it. Okay, and the arsenic concentration in groundwater is dependent on the value of redox potential. We already mentioned that. So redox potential is one of a good indicator for the arsenic contamination. This is a last case. It's when I stay in the Indonesia is from 2005 to 2007. So we conduct several site investigation. So this is a copper mine in West Java. Here this is a temporary stop to avoid the loss from the falling price on copper. So this is an open pit, and then this is a waste dump, and then this is a recycle pond, waste dump here, processing plant, and then this is a tailing pond, the office, and the waste dumping area. This is a picture for the copper mine. This is also copper mine. So we collect the water sample here, and then we analyze it. So we found arsenic one here. Arsenic concentration is 41 ppm. But this isn't not drinking water. So you know that drinking water is a 10 ppb. 10 ppb is 10 ppb. But here is a 41 milligram per liter, ppm. There, if you convert it to ppb, is a 41,000 ppb. See, it's very high concentration. Arsenic is we found it. pH is very low. Then this is a sampling point for soil sample. This is a sampling point. And then we found a lot of arsenic in here. This is a milligram per kilogram, ppm unit is very high. That means that copper mine has potential to release the other arsenic. So that one in soil, in water, and then soil. And then that one released to the other groundwater is contaminated. In Korea, we have several cases. But the concentration of arsenic in groundwater is not so high, around 50 or 60 ppb, but more than around 5 or 6 times higher than the Korean standard. but it is potential. One, you don't treat it and then just you really put it there, is arsenic, really contaminating groundwater. Once groundwater is contaminated by arsenic, whole aquifer is contaminated. So that's the reason you should protect that one. And then this is arsenic concentration also very high in soil samples. Once that one also can reach out continuously. Rainy season, that arsenic is keep coming out. Also, you see, is up here in water sample pH very low. See, if we contact the other very this is a drainage very low, like acid drainage is a contact with the other arsenic contaminated soil, all arsenic is comes out, reached out. So that one is contaminated to the other area of the other mine. That's problem. In Korea, we had this very big problem for this. This is one example, in your country, copper mine. In Korea, we have around 5,000 abandoned mine. So they have no owner, and then they put all the tailing everywhere. So that's the reason is from tailing, a lot of arsenic is reached out, and the heavy metals. Cadmium is reached out, and then that one affected to the other like a farm area. See here, this is a paddy soil here. They cultivate the other rice. So, but fortunately, we checked the other concentration in paddy soil, but arsenic concentration was not so high. But in Korea, we had that kind of a problem in the rice. And then I conducted one project in Korea. So we collect the soil sample, and then we collect all the cultivate, for example, rice, and then cabbage, and then other vegetable. We collected, we analyzed the arsenic, and then we found there's a big relationship between that. That means once soil is contaminated, that one transport to the other vegetable and crop, and then people consume that. That one is a risk to people. So that reason is Miracle is trying to remediate the other soil, soil, and then contaminate the other soil area, this area. And then we are trying to protect all the tailing. This is a waste dumping right here that we just collect it, and then we put it in tailing dam to protect the other problem. In Korea, another big problem is, for example, here they put the waste dump here. That one is after typhoon come here, and then that one all released to river in Korea. And then the whole river sediment is contaminated by arsenic and heavy metals. And then government is trying to put a lot of effort and the money to remediate that. So that's the reason in Indonesia, if you control right now, you can save money later. That is one of our experience, is a lesson from the Korea. Thank you very much for your attention. Yeah, I finished my presentation. Thank you. You have a question, and then please let me know. Thank you very much. Terima kasih.
Okay, thank you so much, Mr. Thornbeck, for the marvelous presentation. And it looks like we already have so many, a few or even so many questions. All right. So let's start to the first question. The first question is from Mr. Halason Simanjuntak from SKF's Widen Company. The questions are about arsenic. There are 3 questions, but okay, let's just start. The first question is, does boiling water get rid of arsenic? And then how can we prevent arsenic in our daily life? And also, what removes arsenic from water? What are the cheapest ways and the easiest ways?
Yeah.
Okay.
Yeah. First one is how we can avoid the other arsenic, right?
Yes, sir.
Yeah. The second one is how we can treat it. Yeah. So arsenic, how we can avoid it? Yeah. So we have to find the clean groundwater, and then usually mining in Korea, most of groundwater is contaminated by arsenic because of mine activity. So, one suggestion is that, like, if you live in the mining area, so I think you should check the arsenic concentration. So we can collect the water, and then you can send the commercial lab, and then you can get the other information. So arsenic concentration is high. This is a carcinogen. You can get the cancer. So you should avoid that one for you and your family. A second question is how we can treat it. There is a treatment method. As I mentioned that before, like we can apply the other sand filter, and then but the other also we need like a composition of groundwater. For example, iron concentration is very high in your groundwater. We can just expose to air and then oxidize it, ferrous to ferric, and then we can treat it. We can apply the other sand filter. Another one is we can using RO system, but this is very expensive. But their RO is usually in US, they're using that one. So also another one is adsorbent. We developed the adsorbent GFO. GFO is a granular ferric oxide. This is a granular form. So this is work as adsorbent. And then groundwater pass through this adsorbent, and then really arsenic is captured in that granular. And then also that time is we developed the granular titanium dioxide. That one also adsorbent. I developed, and then that one also can adsorb the arsenic. But the problem is costly, very expensive. Very expensive. So the best way is trying to avoid the other arsenic contaminated groundwater. That is the best solution.
Okay, thank you so much, sir, for the answer. And shall we move to the next question, sir?
Yeah.
Okay, the next question is from Louis Fitri, UPN Georgia, and the question is, why does the study area contain a lot of arsenic? Is the high of arsenic because the water flowing in the rock? And what kind of rock that contains arsenic? Or is it because arsenic is anthropogenic? Thank you, sir.
Yeah. So this is a natural occurring. So I mentioned that before, like usually the other arsenic is associated with the gold. Is gold. So this is a kind of it's a mineral. This is that I mentioned that is a sulfur mineral. Usually sulfur mineral is associated with the arsenic. So that's reason. Usually arsenic is once we expose that one to air, and then that one is released. One of the reason, like AMD is a similar way. AMD is once we sulfur mineral exposed to air, and that one become the sulfuric acid, and then that reduce the pH and then release the other metals. Similar way is arsenic can release like that. So in anaerobic, that means anaerobic condition is it's stable. It is a mineral form. But once we expose to air, that one generate the problem. So that one also related to our mine activity. Yeah. So I don't know. That should be answered. Okay, enough or not? Yeah.
Yes, that's enough, I think. The next question is from Thomas Petranto. The question is related to the project in copper mine West Java. How is the groundwater direction? Is the arsenic flowing directly to the river, or how about the river water quality? Thank you.
Yeah. So we had this very brief site investigation. So we didn't do the detailed site investigation, but we collect the other groundwater samples. But fortunately, we couldn't find any arsenic and heavy metals. That means that's safe. So also we didn't check the other groundwater flow direction, but we little bit worry about it. Once they activate more and then they contaminate water, get into the aquifer. That one may affect to a lot. Yeah. That is my conclusion. Yeah.
Okay,
Thank you.
the next question is from Rahmat Fajar Lubis. Based on your research experience and the geological condition, where we can find the groundwater with rich arsenic concentration in Indonesia?
Yeah, yeah. So best way is like we should analyze arsenic. We should
Yes.
analyze arsenic. Yeah, because
Yeah.
this is I mentioned that is other parameters. That one is we know which area is contaminated by arsenic, and then we can predict that one based on that. But that one is only for reference. But is we should get the right information. So we have to analyze arsenic. Usually the spring water has also a lot of arsenic. So that's reason in Japan the spring water their water quality standard is 1 ppm, 1000 ppb. So once we going to spring water, if we drink it, be careful. You should be very careful. Yeah. So it should be potential in Indonesia, in spring area and mining area. Yeah. So best way is to analyze it, arsenic.
Yes.
Collect sample and then send the commercial lab. This is the best way.
Yes, I couldn't agree more. And then, sir, the next question is from Fatima STMSG. The question is, do you have any groundwater data which contaminated by arsenic from coal? And is arsenic concentration higher or not lower than of minerals?
Yeah, just yeah. Could you
repeat? Okay.
Yeah. Sorry. So
Okay, that's all right, sir. Do you have any groundwater data which contaminated by arsenic from coal?
coal.
Yeah, coal.
Coal. Usually, coal mine has no arsenic problem.
Mm.
Usually. So also this one, that time is we investigate there's a copper mine. Also we investigate the gold mine, and then we investigate the coal mine. Coal mine is very clear, no heavy metals.
Okay.
Only iron and manganese is a problem in coal mine. So coal mine, you don't worry too much about the other heavy metals. Main issue is like a pH, right? And the manganese should be problem, and iron is a problem for the discharge. And then because there are discharge limit for the coal mine, and other gold mine, we found some arsenic. Is in Bogor. We visit the Antampongkor.
Yes.
Antampongkor, but they manage very well. And we couldn't find any arsenic in river water and other things. But we found that one in tailing dam. In their tailing dam, there is a lot of arsenic there. Yeah. So is also the metal mine. Usually gold mine is main things, and then also I mentioned that the copper mine has also arsenic there. You should manage very well. Mm-hmm.
Yes, that's great. Yeah. And then the next question is from Debbie PP Bandung, and the question is, if arsenic contaminates the oceans, which have large waves, the impact of its distribution will be even wider. How to reduce arsenic and how to stop the spread of its effects?
Yeah, so the God, I mentioned that the methylation is God made, like a detoxification process. So we expose a lot of inorganic arsenic. But as I mentioned that is arsenic 5 change to arsenic 3, especially in ocean. Arsenic 3 change to organic arsenic, right? Organic arsenic, and then less toxic form. So it's God made this kind of a detoxification. So we are safe. So that's the reason is we don't worry too much about that. It's like naturally, we call the natural attenuation. As a naturally, arsenic toxicity is decreased. Arsenic is remain, but the arsenic form changed from inorganic to organic form. So you don't need to worry too much about that. Yeah, but other case, mercury is a reverse. Inorganic mercury changed to organic mercury. That is very, very toxic. So that one affected to a lot. I think that one also in big issue in Indonesia because you using a lot of illegal, gold miner. They're using the other mercury. That one inorganic is released to air, so it will be okay. But once that one going to the river and then ocean, and then you stay the accumulate in sediment, bottom of a river, that one changed to organic form. So that one very, very toxic. And then that one affected to a lot.
Okay, sir. It looks like we are getting more questions. So
Yeah.
just like move to the next
Okay.
question.
Yeah,
That's okay.
yes.
Okay. All right. Thank you so much.
Mm-hmm.
The next question is from Febri Anggara from Geological Technology, PP Bandung. The question is regarding why the water in swamp areas like Sumatra is mostly is most. Can I repeat the question from the start? Regarding why the water in swamp areas like Sumatra is mostly brownish yellow, does the swamp affect the water quality, both pH and arsenic in that area?
Maybe Sumatra, but I didn't analyze it. But from the other document, is usually the other Indonesia is safe for arsenic contamination in groundwater. The yellow mean is a lot of iron there. So that one is very popular in the world. Even though the other you going to the other country and then Vietnam and Cambodia and then other country, there are a lot of iron in groundwater. That is main problem. So actually the US iron itself is not harmful. If you check the vitamin, you check iron, copper, you also copper, but no arsenic. No arsenic is not good for health. And the iron itself is good, but why we control why the government, US EPA or other organizations set up the arsenic, the iron standard. One of the reasons is iron itself can absorb a lot of heavy metals. So that's the reason they controlling iron. And then also the smell is not good and the taste is not good. So that's the reason we control the iron concentration. But iron itself is not harmful. So even though the yellow one, even though there is only iron there, will be okay. So don't worry too much about that. And then arsenic is not much problem in Indonesia. I know, yeah. Only mining area. Be careful in mining area. And the I mentioned the most important, most important like a contaminant is like mercury. So that's the reason is we are last years we get the project from the Korean government, and then we're gonna conducting the mercury project in Indonesia. And so we're gonna conduct a project for 4 more years from now. So that reason is I'm gonna visit the Bandung or like other regions for the other research. And then we're gonna have like collaboration with the Pepe Bandung too. So maybe later, maybe if it's possible, maybe I can meet you in your lecture room. Thank you.
Okay. I think due to limitation of the time, we can just choose 2 or 3 other questions.
Yeah, no problem. Yeah,
okay,
up to you.
Let's just choose maybe 2 questions, right? Okay. From Hikmat Alamsyah. What do you think about contamination in Indonesia? You know, Indonesia has 2 seasons. If the contamination in Indonesia is very dangerous, what is the solution in your opinion?
In Indonesia, the main problem is that there is no standard for soil. Because in Korea, why we operate the mine, Miracle is remediate the other site, especially the soil, land, because one of the reason is we have a law, we have a standard. So we have the government have to follow the other government agency, and they all follow the other our regulation. So that's the reason we have to treat it. But in Indonesia, there is no regulation for soil. For example, copper mine, we found a lot of contamination there based on the international standard. We call, I can say is contaminated. But in Indonesia, if we apply the Indonesian regulation, it's not contaminated because no regulation. So it's like but when you make a regulation, it is like a costly, and then we put a lot of effort because one of the reasons in Korea is a very small land, so we can make regulation quickly, and then we can apply quickly. But Indonesia is a huge land, so if you want to make a standard for the land, I mean soil, you should collect all the samples from each region. So we have to check the background first, like a baseline survey. Maybe it takes few years to do, put a lot of effort. And then based on that, you should make like a soil standard. So it's a very limitation for that. So maybe I hope later, maybe you should make some that kind of regulation in soil. And also another one is, for example, mercury. There is no standard for mercury, only in drinking water, and then only the other in stack exhaust gas. Only you have 2 standards for mercury. So that means people can release mercury to the river, no problem. So how we can treat, make the other, this is a management in the government, they have to put some effort for that.
Okay, thank you so much, sir. And maybe the last question is from Boa Suhat. I choose for because it is the last question. I choose randomly. Boa Suhat from Institute Technology Bandung. The question is there any method to distinguish the arsenic content in water caused by natural process and arsenic content in water caused by human activities?
Yeah, this one is difficult, but like we have to check that's the reason we have to check the other site investigation is the most important. Why is first we found the arsenic. Where is it from? Is from that, this is a research part, and then we're gonna figure out this one is from the man-made problem, anthrogenic activity, or naturally. So we should find out that way. Another way is like we using the other isotope, yeah. So we can apply the isotope. Isotope means is like this from that is anyway, it's very difficult to explain to you. So this one is like a radioactive material. So this one is each has like, for example, lead has like we call arsenic, inorganic arsenic and arsenic. And then, but there is some other radioactive part. So it's from that, we utilize that one, then we can trying to find out the other source from that. So recently in Korea, we are doing a lot of research for that. So where is this one is from where? And then we using is an isotope method to apply, and then we're gonna find out why we doing this one. because government find the other like a contaminant, but government trying to find who made that kind of problem, and then they have to give the big fine. So that's the reason government trying to find out who released that one. So that's the reason is Korea now developing that kind of method.
Okay, thank you so much, sir. And it looks like we have another question who would like to ask directly. Open mic, is that all right?
Yeah, it's okay. Yeah.
Okay, for those who want to ask the question directly, open mic. There are two people who raised their hands, Addison and Addison, Mr. Addison. Okay, you can open your mic and then ask your question directly. Mr. Addison? Is there any problem? Or you can chat the question to the Q&A section, maybe?
Hello.
Okay, or to Riyadul first. Okay.
Okay. Assalamualaikum warahmatullahi wabarakatuh. For that, maybe my name is Riyadul Ulum. I'm Metallurgical Technology in Polytechnic Energy and Mining Bandung. I want to ask to Mr. Sandbeck, what between arsenic 3 and arsenic 5, which one is most dangerous? In the slide, there is what between arsenic 3 and arsenic 5, which one is most dangerous? Thank you very much.
Yeah. So that's important. Is I explained that arsenic 3 is I mentioned there's a lethal of LD50. Is arsenic 3 is more toxic than arsenic 5. So, but these are very simple things. We can convert to arsenic 3 to arsenic 5. I didn't tell you. You have like a bleach. For the other, you're cleaning your toilet or something, you add a bleach. You put the drop of bleach, arsenic 3, change it to arsenic 5. So is one of the things is that reason is when we conduct the other project in Bangladesh, we add hypochlorite. This is a solid form, and then we add that one into the other iron pellet. And then once they add it, arsenic 3 change it to arsenic 5. And then it's very easy to remove. Before, I think I explained the other like a graph. Arsenic 3 itself is very difficult to treat it. So very important thing is like we should convert to arsenic 3 to arsenic 5, then treat it. And then we can save a lot of cost. So that's very important. I missed that one, but it's a good question. Yeah. So arsenic 3 is a toxic, but usually before treatment, we change arsenic 3 to arsenic 5. That is a very important part. Thank you.
Okay, Mr. Thank you very much.
Yeah.
Okay, is there any other live question? Who would like to open the mic? Okay, I'll be waiting. If there is no other questions, maybe it's the end of our webinar session. Thank you so much for Mr. Sandbeck for answering those questions and for the marvelous presentation. It was a pleasure to have you with us. And we got so many good questions, but I think we have to choose two best questions that you think are the best for some door prizes. Which questions do you think are the best? We can choose two questions. Yes.
Okay, I will give you last one.
To Riyadul Ulum?
Yeah, very brave. Open question.
Yes, open the mic. And then maybe you can choose another question, best question from the Q&A session.
Another one? Select one more?
Yes, one more, sir.
a lot of questions. I forgot.
Yeah, too many good questions, I guess.
Yeah, so I will give
so
you
many.
the first one.
The first one
Question.
is that asking, does boiling water get rid of arsenic, and then what
Yes,
do we
right. I will give you the first and last one.
Okay, thank you so much. So
Yeah, last one is
congratulations.
the first for the open question.
Yeah.
Yeah, so I like the first one.
Yes, I agree.
Okay, thank you.
Yes, congratulations to Mr. Halasan Simanjuntak and for Riyadul Ulum for the great questions. So we are finally here, and I can make some conclusions. So the conclusion that we can make is that elevated arsenic concentration are found in groundwater and surface water due to anthropogenic activities and natural processes, and can cause liver, lung, kidney, and bladder cancers as well as skin cancer. Even though the percentage of arsenic in Indonesia is not as high as other countries. Therefore, we need to determine important things related to arsenic, such as toxicity for arsenic species and symptoms of arsenic poisoning, a recovery check for arsenic species, to researches the side effects of arsenic. So this concludes the webinar. Thank you all for attending. We hope you have learned and enjoyed this webinar. And maybe Mr. Bang, we can take some screenshots to as some documentations for our special webinar.
Yeah, I think you operate this webinar is great. And I mean, yeah, I'm surprised. So you manage very well. And then if you want, and then request me, and then I'm willing to come to join your webinar anytime. And
so
also
much.
I want to share our experience, and then I hope we're gonna have more collaboration, further collaboration between the Pepe Bandung and Miracle. And then I hope, and then I look forward to seeing you all, in Indonesia, in Bandung, in my second hometown. Yeah. So I'm planning to go to Indonesia June or June. So this is my plan. Yeah. So I hope I hope can see you all, in Bandung. Thank you very much.
Yes, sir. I'm so amazed by your experiences. Those are some great experiences. Thank you so much. I think we can take the screenshot of Fatur and the operation on all the panelists. I hope you all can turn on the mic feature.
Thank you, Ilham Nur Hakim. Before that, sir, we can for turn on this camera to operator, maybe in instruction.
Korea.
Freedom style, sir.
Yeah, it's love. You love, yeah.
3, 2,
Heart, yeah. Heart.
3, 2, 1. Cheese. Another, sir.
One more.
One more here. Yay. Victory.
Maybe style inside, sir. Kayak I.
That is the symbol of
inside
webinar.
Inside webinar, sir.
Oh, it's both.
Yes,
you director. I gonna follow your director. I like it. Heart with the victory.
3, 2, 1. Cheese. Okay. Thank you so much, sir, for your coming.
Yeah.
Okay. Thank you, Ilham Nur Hakim from the Mining Technology for being the moderator of today's event, and also the presentation from Mr. Sumbek Bang, PhD, was very informative for all of us. Thank you for coming, sir, and Mrs. Thank you so much to join us with webinar. Let's us a given festive impression by turning on reaction, maybe reaction feature, insight, excitement, exactly for today event. Thank you so much, sir. For the lecture PP Bandung, we mail another when say something.
Mohon izin, Pak Fatur.
Yeah. Okay,
Thank
sir.
you once again, Mr. Bang, for sharing your knowledge and experience in arsenic contamination in groundwater. Even it's not a big issue in Indonesia based on your explanation, but I think we all believe that everything about groundwater is important to learn so we can control all issues. And as Mr. Bang said that, and I totally agree with Mr. Bang, if we can control today, we can save money in the future. And I visited Argo Tunnel in US, and the site shows us that how US government spent a lot of money just to normalize acid manganese from abandoned gold mine. And we have to learn from that. I think there is a lot of lesson learned from the Argo Tunnel. And I think Mr. O can explain about acid manganese for the next webinar. And thank you again, Mr. Bang and Mrs. O. Thank you. Thank you very much. Terima kasih.
Terima kasih.
Terima kasih.
Thank you for Sir Asep Rahman. Okay, next. Disclaimer, don't leave the Zoom for 10 days, the audience, because there is interesting door prize for 3 lucky people, and 2 best question is Sir Radul Ulum dan juga and Mr. Alaslon. So congratulations for 2 best question. Okay, for 10 days, because soon there will be interesting games and door prize session with 3 lucky people. For panelists and Mr. Sun Beng and Miss Yon So, thank you so much for coming. Are allowed to leave a Zoom session? So thank you so much.
Terima
Also
kasih.
still owing, sir. If you still want to follow until the end of the event, surely. Thank you, sir, for in advice for the time and knowledge, sir. Thank you so much.
Terima kasih, Bapak.
Okay.
Terima kasih. Terima
Thank
kasih.
you so much, Mr.
Terima
Bang
kasih,
sir,
and
and
Mrs.
Miss
Yun
Yon.
Sudol.
Okay, the next event is a game, namely the Kahoot quiz. I think Kahoot is a pretty familiar for us because there will be 3 lucky people and 2 best question prize from PP Bandung. Let's join the Kahoot now. Maybe operator for giving code to Kahoot code.
Yeah. Thank you. Yeah, see you.
Thank you, sir.
Yeah.
Bye-bye.
Time. Okay, disclaimer, you can use the Kahoot code provided by operator and the format of username itself _intention. For example, Alpha Turiski _PB Bandung.
You all can start joining the Kahoot now by enter the code.
It code 9852174.
Who will be waiting now?
Maybe Ilham to help me for this game.
Yes.
Yes, thank you.
We are still waiting for the players. You all can join the the game. All of you. It's just a game, right? So no hard feelings, no. Have you guys joined it?
Yeah,
The
join
game?
in Kahoot game. Novi, maybe share screen for code game. Any trouble? Okay. Okay, Ham. Novi, monitor Novi, nak. You can share screen. Oh, thank you. Sorry to attend this. Maybe it's like trouble. Wait a minute. Yes lah. Oh, Ilham. 26 people
Okay,
is
28.
join this.
We can
game.
wait for another 5 minutes, Patrick, or maybe 3 minutes. Okay.
Yes. Repeat. Pardon me. Pardon. Huh?
Okay, we are getting a lot of participants now. Let's just join. We have some special the prices, right, Patur? PP Bandung always provide special
Yes.
merchandises or
Special merchandise from
yeah,
PP Bandung.
Pepe has so many good
So many good for.
merchandises.
Hey, by the way, what you feeling for moderate for this event?
Well,
Uh,
I'm so excited
what's-
because I'm able to moderate this event, this special webinar, especially this webinar this time. We are able to use English, like fully English during the webinar. So it's something new for me.
yes, me too.
Yes.
It's something new for me, for us, yeah, for us.
Yeah.
Yes,
And
maybe
I
like, yeah,
think our first English webinar in PP, right?
yes. Okay.
Okay, we got more.
Next, we have next event from Korea. Huh?
Yes,
For
from Mrs. Lim.
14 April and 21 April.
Yes.
Yeah, for attendance,
Oh,
maybe
come back
interest.
or is there any imposter, any imposter that using Mr. Bang's name?
Yes,
Please use your real name because if you win the Kahoot,
yes,
we are going to send the door prize to you. So it will be a struggle for us if you are using fake name.
yes. First name and extension. For 3 people, right?
Yes, for the
Yeah. Oh,
the highest points, for the highest 3 points.
I forget something. This game contain question from the materials that has been described by Mr. Sunbek Bang. Anywhere who also join the YouTube live streaming too can join this Kahoot.
Okay.
Okay.
I guess that's enough, right? 65 participants.
Yes,
Let's
it is
see
5
how about we
participants.
start this Kahoot now.
Yes, last start begins maybe.
Okay.
For operator,
The operator, you can start the
yes, you
Kahoot.
can start. So excited, Ilham.
Yes,
Inside 3 point.
something new for us.
Question number 1. 1 of 17. Oh my.
First question. Okay. Wow,
Where does a message from Big Bang come from?
where does Mr. Trump bang from? I think it's obvious, right?
Ah, 3 false.
We have Rafi.
Wah, Rizky Raffi, congrats. What the conclusion? Apa ya? Conclusion in graphic. Wow, it's so hard.
We are going to like a pretty harder questions, I guess.
But attendance apa ya? See materials maybe can answer for the 17 question maybe. Wah, number 1 is number Ananda Isan underscore KP. Manakah yang paling berpengaruh?
Brown sugar. Let's see who's on top of our Kahoot. And they stand on top of the Kahoot.
Senet or ICP is inorganic arsenic.
7, 6, 5.
True. Oh, 40. Yes. Number 9 of 17. Which country that have the most arsenic contamination issues in this world? Maybe to Pekseku, mau lihat Taiwan, Bangladesh. Oh, 49.
Okay,
Katika is a leader for leaderboard now. Number 10 of 17, this either of termite or of arsenic contamination, except losing control, body and show, menyanyi nih, is to Pamungkas said, lame lang, is lame. Oh, yes. For the apa ya? OTP spirit maybe for the winning this challenge. Anak-anak PP semua nih. Mantap. It is number 12 of. It's difficult for snake to remove. Predominant is the false. It's true or false?
Apakah yang memenangkan webinar ini sama dengan pemenang yang webinar minggu kemarin? Kita lihat.
Yes, I don't know ya. Who don't know. It's a mix in bahasa and English question ya. Apa yang menyebabkan pertambangan tambang dihentikan sementara berarti?
We have 4 more questions now.
Choice what? A. Number 15. Data sampling Rico. Terus kandungan apa yang memiliki intensitas tinggi pada air tanah di sana? Fe or besi, boba, arsenic, or yttrium. Wah, the last question. Ilham, mineral apa yang tidak berasosiasi dengan arsenik?
Let's find out who are the winners.
Yeah, let's find out. Top 3 for leaderboard. Oh. Podium. Inside 3.0. is number 3. Congratulations for Dandi, teknologi geologi Kak Dandi. Runner up ada Kak Vidya underscore PP. Congratulations. And number 1 is Rizky Rafi underscore PP. Congratulations for top 3. Ham ya. Top 3 because
The door prizes maybe contact to BP or for who? Okay.
yes, for congratulations for the top 3 who have been mentioned. Please contact Dikri or Naufi as the operator is in the private chat by including your full name, full address, and phone number. Don't forget to share for operator and to base question to base question.
The best question as well.
Oh yeah, mention to contact of as contact Naufi and Dikri as the operator in the private chat by including full name, full address, and phone number. And we are final session, Ilham.
Yeah.
Everything is share, maybe screenshot ya, screenshot as a documentation. Hopefully, all friends, ladies and gentlemen, will still join turn camera to place for operator to help for